What is a black hole? Enter Schwarzschild radius, the minimum radius required to form a black hole. If we want Earth to be a black hole, we need to densely pack Earth to 9 millimeters to make a black hole, and will be equivalent to a marble size. And on the other hand, if we want Sun to be a black hole, it will take a Schwarzschild radius of 2.5 kilometers.
A black hole is a volume from which matter cannot escape, and at the center, the gravity becomes so high and becomes infinite that even we cannot measure it with the highest equipment that we have.
When the extreme amount of space is concentrated in a tiny space, at the center, the gravity becomes infinite, resulting in a black hole. Whatever goes closer to it rips into its elementary particles, even stars.
Anytime it takes any particle, it increases its surface area.
It turns out black hole increases its space as a tiny bit of information it collects.
In 1974, Stephen Hawking, who derived Hawking radiation, black hole emit electromagnetic radiation in a form of energy.
The information is transferred right from the beginning of the universe. If somehow we capture all the information or energy ever transferred and convert and recycle the information and get back into readable text, we can know everything right from the beginning.
It can change shape, but the information can never be lost. But black hole makes things complicated.
Enter to the black hole information paradox. Imagine a thing thrown in a black hole. According to Stephen Hawking, Hawking radiation will release. More on that later.
But according to law of conservation of energy, energy can only transfer from one phase to another. Let's suppose this wood. It's going to be coal after a few time, and then ashes, the secondary and the tertiary compound of it. But in the case of my knife, if I'm going to throw my knife into this wood, let's make it kind of bigger. My knife is going to be converted into coal, even though it is made up of stainless steel, not the molten stainless steel. This is what happened in the information paradox of a black hole. Whatever goes in, the information that comes out is going to be the Hawking radiation, which has the same amount of energy. The Hawking radiation and the resultant of it, it's going to be the same forever.
I have no idea. The expedition wasn't known to me. They have decided me to send in a black hole.
As I crosses the event horizon, I will be trapped inside it, because everything inside a black hole is traveling faster than the speed of light towards the point of singularity.
To me, inside a black hole, seconds will feel like minutes, and minutes will feel like weeks, and weeks will feel like months, and it will go forever. Years, then centuries. Time will be slow for me. And if I about to get a window from a black hole to the other way, mean the researcher or the expedition who was watching me, the time that I will see for them will be so fast, and I can see their future.
From outside, I cannot be seen after I crosses the event horizon. Okay, wait. Black hole emit radiation. Enter quantum fluctuation.
Empty space is not empty. There are constantly particles annihilating and annihilating each other.
When a particle enters at the edge of a black hole from quantum fluctuation, one particle will go inside and another will come outside.
Once I crosses the border is completely separate from the rest of the universe. I don't know what will happen once I crosses the boundary.
We don't know what will happen once we cross the boundary. When we see black hole, we can't see from our eyes, because light bends the fabric of space and time. And when we see a black hole, our eyes surpasses or bypasses the area.
For one side, it is a problem. We can't see a black hole and nothing goes away. But on the other side, it is a great idea to see distant galaxies.
And that helps us to see distant galaxies from a black hole to a gravitational lens. The way we identify a black hole, the identification of its position, is to measure the gravitational field around a black hole and the gravitational field that a star experiences towards the nearby stars. There is no way to tell what happens to a person when he falls into a black hole.
Recently, some researchers have proved energy can escape from a black hole. Otherwise, showed energy can escape a black hole.
Stephen Hawking further suggested that this claim that there could be a way out of a black hole when he famously said, "If you feel that you are in a black hole, don't give up. There might be a passage to another universe. But you could not come into our universe back again."
I was unknown there, a one-way journey. Because the boundary opens in one way. And the rest was a history.
That is why string theory suggests multiple dimensions. Am I two right now? And as always, thanks for watching.